In this lesson, I will explain to you the concept of correlation, which is one of the most important topic in statistics. The objective of this lesson is to answer these questions statistically. Right, the first question is, are two or more variables related? Because we are discussing correlation between two variables. One variable we have to take on x-axis, which is the independent variable, and one variable we take on the y-axis, which is the dependent variable. So in correlation, we have to discuss these four questions or these 4 points in order to understand the concept of correlation. So the first is, are two or more variables related, independent or dependent variables? Second is, if yes, if you say yes, they are related, what is the strength of the relationship? Third question is, what type of relationship exists? And fourth is, what kind of predictions or conclusions can be made from the relationship? So these are the 4 important points which we have to discuss in order to understand the correlation. Move on to the second slide. Here I have written the concept, or you can say the definition of correlation. That is, what is correlation? Sorry, correlation is a statistical method used to determine whether a linear relationship between variable. See, the word or the focus is on linear, and linear means line. So we will see, I will show you with the help of few questions. When we will draw the plot, you will see different types of line. If you will see the straight line like this, it means we have two variables, as I have told you. Independent variable we have to take here on x-axis. Dependent variable we have to take on the y-axis. This is our y-axis. When we will make the graph, when you will see a straight line, this is means linear, right? You can have a straight line like this or this, which I will show you in the next slide. But this is the concept of correlation. Here you have to find out whether or not there is a linear relationship between two variables. Or you can say correlation is defined as a measure of linear relationship between two quantitative variables. Or you can say correlation is a single number that describes the degree of relationship between two variables. Simply, you can say that correlation shows the relationship between two variables. Linear relationship. It shows the linear relationship between two variables. The first two questions, as I have told you that in order to understand correlation, we have to discuss 4 points. So the first 2 points are two or more variables related? Related means if suppose one variable is increasing, the other is increasing. Or if the one variable is decreasing, the other is increasing. So are two or more variables related? If so, means if you say yes, so what is the strength of the relationship? In order to understand these two questions, I have written here, to answer these two questions, statisticians use the correlation coefficient. I will show you how to calculate the correlation coefficient. There are different types of correlation coefficient. For the population, correlation coefficient is represented by this symbol, and for the sample, correlation coefficient is represented by the letter R. So in this lesson, we will focus on the sample correlation coefficient, which is R. This is the numerical measure to determine whether two or more variables are related and to determine the strength of the relationship between or among the variables. Usually we take two variables. If we take two, it says between, or if we have more variables, so we can measure the relationship among the variables. One thing I will tell you later on, but here simply I say this R. The correlation coefficient range is between -1 or -1 to +1. Now for the third question, what type of relationship exists? So there are two types of relationship. One is called the simple relationship, other is the multiple relationship. Now what is the difference between simple and multiple relationship? If we are considering two variables, then it is called the simple relationship. If we are considering 3 or 4 variables, then we will say it is a multiple relationship. Simple. But again, we will consider the simple relationship, or we will consider two variables. See here I have written, and one is called the independent variable, which we take on the x-axis. One is called the dependent, which is we take on the y-axis, right? Independent variable, this one is called the predictor or the explanatory variable, while this one, the dependent variable, is called the response variable. Come to the fourth point. What kind of predictions can we make from the relationship, or what kind of conclusions we made? So on our daily basis, we make predictions. For example, weather forecasting. If we will see outside home, the temperature is -40, maybe there will be snow. Or if the temperature, suppose if it is cloudy, we will say, okay, the rain will be there. So rain depends on clouds, right? Simply we can say. So this one is the independent variable. This is the dependent. This is the simple example, but I will show you with, I will solve the question with the help of some examples as well. Okay, examples include, and the stock market, if we have a good economy, right? Economy we will take on the x-axis, and then stock market price we will take on the y-axis. Similarly, sales predictions, if we have a good advertisement, so advertisement we will take here on the x-axis, and sales depend on advertisement, so sale we will take on the y-axis. So this y-axis is the response. Here I have written, right, go back here, response variable, and x-axis is the predictor variable. Okay, so some predictions or some conclusions are more accurate than others due to the strength of the relationship. That is, the stronger the relationship is between variables, the more accurate the forecast is. So we have to find out the relationship. If we have a strong relationship between these two variables, then it means our forecast or our conclusions or our predictions are accurate. So how we will find out that what is the relationship and how we can calculate the relationship? So we plot the relationship of two variables in the form of scatter plots. So here I have written the independent and dependent variables can be plotted on a graph called the scatter plot. Now what is the scatter plot? I will show you the next slide. A scatter plot is a type of data display that shows the relationship between two numerical variables. Independent, here I have again written that independent on x-axis and dependent on y-axis. Independent variable can be controlled while dependent variable cannot be controlled. Now what is the meaning of this? And this is the very important line, that independent variable can be controlled. Here is the example of attendance. This is the independent we will take on the x-axis, and our grade. So our grade depend, or our percentage depends on our attendance. If we miss suppose only one class, maybe the percentage is 90. If you will miss two classes, maybe your percentage will be 80, right? And the point will come here. Similarly, if you miss suppose here 10 classes, maybe your percentage is 40. So see, this is the independent variable. Independent variable can be controlled. It's up to you. Whether you want, you can come 100% in your class. If you want, you can attend only one class. So it's up to you. But grade, no control. It depends on your attendance. So see, when we will join these lines, it will be in the negative direction. So this is the important point, that independent variable is controllable, while the dependent variable, there is no control, cannot be controlled. So when we make the scatter plot, you will see the output like this. If you have an output like this, it is the positive linear relationship. Means if we draw a line like this, right, with the help of few points, our line will go up. So this is the positive linear relationship. Here, see, the graph is like this. This is just the case of the attendance. If you will miss more classes, your grades are decreasing. So if you have a line like this, it is the negative linear relationship. In this case, our both x-axis and y-axis increases. If one variable is increases, other is also increases, then we can have this line. In this case, our one variable is increasing, other is decreasing, so we will have this line. This is no relationship. And here is the curvilinear or non-linear. You can take the example of a stock market. Suppose the economy is good, our stock market is here. If the economy is bad, so it's going down and then again it's going up. So this is the curvilinear. And this is different kinds of different patterns of scatter plots. Okay, now we will move. Okay. Now we will solve same thing, positive relationship or negative relationship, with the help of few questions. Here is the car rental companies. These are the car rental companies and these are the cars, these are the revenue. We have to construct a scatter plot. So see, on x-axis we have cars and here is the revenue, because our revenue depends on cars. If we have more cars to rent out, then we can have more revenue. So if see, I have made these points and this is the graph. If I will join these points, see, from here to here, here to here, or here to here, we can have a straight line. It means if cars are increasing, our revenue is also increasing. This is the positive relationship. And as I have told you, the range of this relationship lies between -1 to +1. This is not +1. Because see, these 2 points are not in the line. It is a positive relationship but not +1. Maybe it is 0.95, maybe it is 0.90 or 0.92 or so on. So I will show you how to find out. This is with the help of this graph, scatter graph, you will see that this is the positive relationship. You can say, we can conclude. But what is the relation? This relationship lies between -1 to +1. So in this range where it lies, it is not +1. Again, these points are not on the line. So I will show you how to find out the correlation between these 2 points with the help of formula. Then what is the relationship, right? So here I have written how to make this graph, which you know, that draw and label x and y, plot each point and determine the type of relationship. This is a positive relationship, right? Okay, now move on to the second example. Here is absences and final grade, the same thing. This is the x-axis, this is the y-axis, this is your number of absences or attendance, you can say. This is your grade. See here, if you miss 2 classes, then you're 86%. If you miss 6, and then you have so. When we will join these lines, so see, these 4 points will be in line and these points are not line, but it is decreasing like this. So this is the negative relationship. A strong negative relationship is -1. But this is not -1 because these points are not in the range. So what is the relationship between these two variables, between -1 to +1? The answer will be in negative, but what? Maybe -0.80, maybe -0.85. What? So I will show you with the help of formula also to find out how to calculate this relationship. Now, this is the age and money. To find if there is a relationship between ages of the people and their net worth. So see, this is the ages. 50, if you are 50, it is net 12 billion. 67, 20, if you are, suppose your age is 60 years and the earning is, or your net worth is 21. So see, there is no relation. It means there is no relation between age and net worth. Right? Okay. Now, correlation coefficient are used to determine the strength of linear relationship. As I have told you, here see, we have like this, but those points are not on the line. In the second example, we have this, but some points are not on the line. What is the relationship? So here you have to use the correlation coefficient. Correlation coefficient are used to determine the strength of the linear relationship. Linear means line. So if we are considering the population, then the correlation coefficient is denoted by, we write like this, or you can say P. But here we are using the sample. So for sample, we are using the letter R. This is called the linear correlation coefficient of a sample data. For population, this correlation coefficient, and for linear correlation coefficient for sample is R, which is called the Pearson product moment correlation coefficient, PPMC. It stands for Pearson product moment correlation coefficient. Right? Okay. Now, the range of the correlation coefficient, as I have told you, lies between -1 to +1. Here I have written, if all points lie on the straight line, it means strong positive linear relationship. If all points lie like on this negative linear relationship, it means strong negative linear relationships. If points are like this, right, just like in the example of age and net worth, there is no linear relationship. So here I have written, if there is a strong positive linear relationship between the variables, the value of R will close to positive R, otherwise it is -1. You can read it, everything will be clear. So these are the linear correlation coefficient. Again, the range lies between -1 to +1. If suppose we have some x-axis point on y-axis and the points are like this, when we will draw it, we will get the straight line. But see, all points are not on the line. It means we can say, or we can conclude, the relationship is 0.50 or 50%. Here, see, points are close. So here we can say maybe the relationship is 0.90. But if all the points are on one line, it means a strong positive correlation. If all points are here, we can say strong negative correlation. One x-axis increases, y is decreasing. One variable increases, other decreases. In this case, both variable increases. Same thing here. This is the negative, but all points are not on the line. Maybe we'll say -0.90. Here, maybe we will say -0.50. Right? Okay. This is the formula. This one is the formula to find out the linear correlation coefficient R for the sample. N is the number of observation, summation of x, y, because usually we have x and y component. X is independent, y is dependent. So the third, we have to make the third column. We will multiply x and y, and then we will make the square of x, this one, and then we will make the square of y. This is the formula. And suppose this is my data. Compute the correlation coefficient R for the following data. The same first example, car and the revenue. So see, our line was like this and 2 points were not on the line. So we have to find out. With the help of this graph, I say this is the positive strong relationship. But strong positive is +1. Here our 2 points are not on the line, if you remember the previous example. So we have to find out what is the relationship. So this, and with the help of this table, we will find out. This is our x-axis, this is our y, right? Then we have to multiply this by this, you will get this. Multiply this by this, you will get this, right? So see, like this. Now square it, 63. So it does not mean that 63 multiplied by 2 you will write down. No, this is wrong. Square means 63 times you have to write down 2 times. 29 multiplied 29, like this, in this way. Same thing for y square. Make the square of this 7 times 49. 3.9.3.15 this. Square it. Then we will sum all these columns. This is the summation of x, summation of y. See, all are added together. Now we have the formula, and then you have to enter all these values. And number of observation 1, 2, 3, 4, 5, 6. So n is equal to 6. This is our formula. N is equal to 6. Now you know everything. X, y, summation of x, y is this. X square, y square. So see, just put all these values here in the formula. And keep in mind there is a difference. X square and summation of x whole square. This is the third or fourth column, but this one is the first column, summation of x, right? And then you have to make the square. Here This is x square. Make the square of each element of the x, then make the total. So when you will simplify it, you will see it is 0.982. Strong positive. It is the between the car and revenue. 2 points were not on the line, right? But if it is a strong, we can say positive one, but it is 0.982. We conclude it is still a strong positive correlation between these two variables, between cars and the revenue. Now here I have made a practice problem for you. Same thing. This is our second scenario. Absent. Here your absence is. Here is your grade, and we have discussed this question in the last few slides, right? So our graph will be here, but few points were not here. It is a minus, so minus something. It is negative strong correlation. But what is R? You have to find out exactly. The range is between -1 to +1, but it is the negative. So it is not -1 because some points are out of order in the not in the line. So you have to find out actually what is R. Now again you have to make one more column x, y, multiply these all columns, and then you have to x square of this column, make the sum total. Same thing for this, right? And you have to make summation of x, summation of y, everything. You have to put all these values in the same formula which we did in the last slide, and you have to find out what is the relationship, linear relationship between these two variables. When you will solve it, the good thing is the solution is also here I have made for you. So the answer should be negative 0.944, strong negative relationship, right? But first you have to solve it. And then I have made one more practice problem for you. This is the engine size. Engine size is independent. So this is the x. Price depends on the engine size. This is y. You have to make 3 more columns like this, right? Make the total, put the values, and at the end your graph will be like this. There will be few points which will be not on the line. You have to find out what is the relationship, correlation coefficient. Answer should be 0.98. It is a positive strong correlation. So in this lesson we have discussed correlation, which is the important topic of statistics. I think everything is clear. If still any point is not clear, you can ask me. Subscribe to my channel, and thanks for watching.